Hello, this is Adrian again with Applied CAX, and for today's Femap and NX Nastran 5-minute tutorial, we're going to talk about DDAM Analysis, or Dynamic Design Analysis Method. This is a naval analysis method for testing equipment on ships that are experiencing an underwater explosion. So that nearby underwater explosion vibrates all the equipment, excites the natural modes, and induces stresses and deflections. So the foundation for this, as with any linear dynamic analysis, is a solid normal modes analysis. That's our first step. We're going to have to make some special tweaks to the constraints for the DDAM analysis, and then finally we're going to have to dig into the analysis tree to figure out how do we turn this thing on. For this example, I've got a little pillow block here. It's ready to run for normal modes, so we'll start with that. One tweak we're going to make here to this normal modes analysis is we're going to step our way through these analysis options until we get to this page here. We want to be sure to request modal effective mass fraction. That's going to tell us how much mass is participating in each mode shape. We'll run this, look at the normal modes, and then take a look at the mass participation. Alright, here's our results. We can deform the mode shapes, 55, 60 Hertz, then we get into higher frequencies. That seems realistic for a stiff, blocky structure like this. Looking at the mass participation under the functions, I want to highlight the T1, T2, and T3 sums. We'll right-click and show these functions in the charting plane. So here we can see how the mass participation sums over the modes. The T1 and T3 directions don't break 80% until mode 3 and 4 respectively, and the T2 direction doesn't break 80% until mode 8 respectively. So we've got enough modes that each of these translational degrees of freedom breaks 80% mass participation. Now let's set up our constraints. The first one I'm going to set up is going to be called our kinematic constraint set. These are going to be the translational degrees of freedom that we want to excite our structure in. I'm going to grab the independent nodes, these rigid elements here. Make sure I've got the right ones. And I'm just going to do the TX, TY, and TZ. We're not using the rotation because our ship is not rotating around our pillow block. It's vibrating in the lateral or vertical directions, fore and aft. And those, we think about this as our shaker table. The next constraint set we're going to do, we'll call this our primary. Even though it's called the primary, I think of these more as the stabilization, the support constraints. So I'll use those same two nodes. And these are going to be just the rotational degrees of freedom. Alright, let's put these into a new analysis. So we're going to go right in here. We're going to make a new normal modes analysis. Let's give this one DDAM title. And we're going to skip along until we get to the boundary conditions. Our primary constraint will go under the primary sets up top here, and our kinematic constraint will be down here under the kinematic or support constraint set. On our output request, we want to be sure that we request stress, forces, and if you're going to be using free body diagrams, which I recommend, about equation force and force balance. Now the tricky part here is drilling in through the tree to activate the DDAM analysis. Click on this and edit. We'll enable the DDAM analysis. We're going to say that this equipment is on a surface ship. It's deck mounted equipment. The only thing I really need to adjust here is Y is my vertical direction, and I want a minimum acceleration of say 8 G's. It's going to be a whopper here. Alright, let's kick off the analysis and wait for the results to load. bring up the post-processing, we can deform and contour the structure. We'll make sure that we're looking at our X, Y, or Z modal response. And down under the contour, we'll take a look at our solid von Mises stresses. So here we can see we get some high stresses around those rigid elements, but overall things are looking good. We can step through each of these output sets, figure out which is our highest, where we might need to change our structure, where we might need to do a bit more advanced post-processing, and that's about it for the DDAM analysis. So I want to encourage you guys to check out our Applied CX website. We've got lots of resources on here, tutorials, white papers, APIs, and if you guys are having some issues, feel free to contact us. Thank you very much for your time, and have a good day.